with that, I will hand it over to Dmitry to talk about state of Sorbet.
Awesome. Thank you, Mike.
Thank you.
Okay. Hello, everybody. As a kind of introduction, Dmitry, an engineer at Stripe, working on developer productivity at Stripe, all things developer productivity, but in particular, the type system that we use for Ruby. Ruby is a majority language used at Stripe. More than 50% of our code is written there. Before this, I worked on Scala compiler. My PhD thesis was Scala 3, at the time called Dotty. Today, I also am part of a bunch of Java and JVM design groups, Project Valhalla, Project Ember, so working on parametric on Java, working on data classes for Java, working on continuations for Java. Okay, so let's get started. This is a plan of presentation. First, we'll go about what's Stripe to give you some context for why did we need to build a type checker for Ruby. Then we talk about what were the goals of building a type checker for Ruby. Then a bit about adoption and a bit about editor tools in the state of it today. At any moment, please feel free to interrupt me, ask questions. Let's make sure that if you're curious about something, we'll get to cover it. Awesome. Okay, so Stripe. Stripe is a platform developer used to accept payments. We run in more than 3,000 countries. Millions of businesses worldwide use us. Billions of dollars processing annually. More than 80% of American adults bought something on Stripe in 2017. We have more than 1,700 people in 10 offices worldwide. Customers believe that they become more productive after deploying Stripe, in particular when they need to accept money. And as always, we're hiring. Now, Ruby at Stripe. Ruby is a primary programming language at Stripe. That said, the way we use Ruby is very dissimilar how some other companies use it. We use a subset of Ruby that was enforced syntactically by a tool called Rubocop around 3 years ago. We're also not using Rails. A lot of Ruby code and Ruby magic comes from Rails. We don't have it. We value explicitness. We don't like action at a distance. We would prefer to write more code, but at the same time, make it clearer to understand and easier for a reader to understand it. Next, majority of the code at Stripe is in monorepo, and that's intentional. We have 10 or so macroservices with a few microservices around them, and majority of code goes into existing service in the monorepo. Now, scale of engineering at Stripe, we have hundreds of engineers, thousands of commits per day, million lines of code. In this world, it was important for us to make sure that as size of engineering at Stripe grows, we have a way to explicitly indicate which promises as a library author do you do to other engineers at Stripe, and which expectations as a library consumer should you have for a library. And this was one of the core things that impacted our design principles for Sorbet. So first of all, we wanted to make it explicit. Many type systems decide to do type inference across functions and across classes. This makes it harder for you as a reader, without having a tool in your hand to tell you the types, to know the types. In languages like Scala, you will be able to do type inference like from one function to another, and you're free not to write, for example, return types. In some languages, you're allowed to not write the argument types. This makes for convenience of writing the function, but at the same time, as a reader, as somebody who's going to observe it, and in particular, somebody who may be working in a code base that you're still writing and it doesn't yet parse, so the tool may not work completely yet. It may introduce hassle that we didn't want to introduce ourselves. So we went for explicitness, where you may be writing more, but you're doing it for the sake of better experience of somebody reading this code after you. The next, what if I refresh? Do I get background? No. The next one is, while we wanted you to write things which made your explicit API, at the same time, we wanted to not overdo this and make you not write stuff that we can do for you. For example, where inside a function, while inside a method, you don't need to say that A is an integer. Despite you needing to declare that this function returns a string, which we could have potentially guessed. For things that are your internal, yes, please. Okay, let me try to increase the font somehow. I'm not sure how to do it. If I try to increase it, it doesn't. Sorry, I tried. What? Do you want to sit closer? If somebody on the back doesn't see, please feel free to move. Thank you for asking. Okay, so yeah, despite us wanting to make we believe it's important to write things that matter. We believe it's inconvenient to write things that don't matter. Next one is, we believe that complex type systems have their use case, but we believe that at Stripe, where engineers have a lot of complexity because our internal systems, because of products, because of the complex areas where we operate, we wanted to have a type system and all of our tools that are as simple as possible while still being useful. The way we phrase this is simple, but not simpler. So because of this, we decided to have the set of features that we discovered one by one that we necessarily had to have them. If we didn't have this feature, it wouldn't have possible to adopt it and make it useful at Stripe. So every feature that Sorbet has was done to either make it possible to adopt it at Stripe, and there's a single feature that was done to make it possible to adopt it on open source that Stripe doesn't use. So we started with Gradual type system, which we're going to go deeper later. The second one is union intersection types, which allows you to model cases where a value has multiple types, like in one branch it's an integer, another one is a string. And after branches join, it's an integer or string, rather than being like some kind of top type that you can't do much with. Similarly, you have like local type inference so that you don't need to write extra types. We needed control flow dependent typing because people when the people get this value that's string or integer, they sometimes will write code that will dispatch differently depending it's either string or integer, and we need to handle this. Of course, you have collections, so you need generics. And then for a bunch of methods in the standard library, notably doublet flow, you need self-types. And we'll dive a deeper. Why do we need runtime typing? So the next one is, from our experience, Stripe code base grows quadratically with time. There's a similar experience that we saw at Facebook. There's similar experiences we saw in other places. Which means it's important and for the type checker to scale. It should scale in terms of team size, how many engineers are using it. It should scale in terms of teams who have very different needs. Somebody may want to be very strict and have everything typed, while somebody may be like still experimenting with something and may want to be lax. It's also important for us to make sure that we make hard decisions early and make it possible to migrate to it and pay price of migration once, rather than having like long-term bleeding migration that everybody has to continue paying the price for. And to give us some perspective on the performance part, which is partially to the growth of code, our current performance is around 100K lines per second per CPU core. To give you some comparison, Java C is around 10x slower, and the tool that we used before, Rubocop, is around 100x slower. And the others were actually benchmarked given a single core. If you parallelize them, they don't get a perfect parallelization, while Sorbet was benchmarked on 64-core machine. Yep. Now, the next one is we wanted to be compatible with Ruby. We wanted to use standard Ruby syntax. And the core reason for this is that we are a small team. At the time, we didn't intend to rebuild IDE, we didn't intend to rebuild linters, and we still are using those tools or benefiting from them. For some of them, as we worked on this, we're now actually building an IDE. But in the process of typesystem being rolled out, it was super important for us to be able to use existing ones. At the same time, we also believe that this is a project that other companies could potentially benefit for. At the time, we didn't know for sure, partially because other companies use Rails and we do not use Rails, so we hadn't had similar experience for them. But we tried with other companies and now we know that it works for them too. So now Sorbet is open source. More than 50 companies are using it. They're finding bugs with it. Many of them are super happy with it. Others are still in the process of adopting it. And probably the most important one is the fact that we wanted Sorbet to be gradually adoptable. What this means is we have a huge code base, a million lines of code. We cannot stop the code base from evolving. We cannot stop teams and ask them, please freeze, please stop doing anything that you were doing, go and adopt the thing, and then we'll unfreeze. We live in reality. we have to be able to like start adopting with different teams adopting at a different pace. Some may not adopt it now, some may never adopt it because they have different constraints. So it's important for us to make sure that this tool can be adopted piece by piece. So we introduced something called strictness levels. The basic one is you get it by default at Stripe. In this case, we're going to quickly check you for some things like syntax errors, whether you're referring to classes that exist. Like you cannot mistype the word integer there. Before this, you potentially could. The next level is type true, where we actually start type checking. In type true level, we will verify that like you're passing the right number of arguments, you're calling functions that we believe exist, you're doing the right things with them, stuff like this. Type strict is the next level, where you're effectively saying that I'm willing to promise that my public API will be typed. Which means I'm going to have a better, I'm going to promise that my users will have a better life consuming me, and that I'll have an explicit contract about how do you use me, what's the correct way to use me, and if you don't, that's misuse. This was very important for many teams at Stripe that were building platforms that happened to be writing code that happened to work with some values. Common example is that in Ruby, strings and symbols are very similar. There are two ways to like pass values. Like, let's say you have a color red. You can pass red as a string red, or you can pass red as a symbol red. And majority of the code will work with both of them. But sometimes you want to make sure that it works exactly the way you want it, and you want to agree on what's the right way to do it. So this allows you to specify this. And in case it doesn't work, to guard you. And the final level is type strong. Type strong is the safest level of typing. As part of gradual adoption, Sorbet has a type which stands for untyped, where if you call a method whose type we don't, return type we don't know, we say that type is untyped, which means you can do anything with it. You can pass it wherever, you can call whatever methods on it. In type strong, you're not allowed to create values of untyped type, which means everything that you do with your value has been checked. We'll check that you're correctly passing it to functions that accept it. We'll check that you're calling functions that we believe exist. This effectively brings you to like level of strictness that like static typing has in languages like Java. And you can decide that per file, I want to be strong, or another file, I'm going to be like true, or even not write an annotation at all. Any questions so far? Good. And another thing which was super important for gradual adoption is runtime type checking. So let's say you have this snippet. You have a typed file A, where somebody wrote a function foo that says the proper way to use me is I take an integer. You have another file B, which is untyped. So you're not going to verify if it's calling functions correctly, and it passes a string. So the untyped file misuses the function foo. Now the question is, if you were to not do this checking in runtime and you were to do check statically, because there is no way for you to check B, because you're explicitly not checking B, it means that foo in runtime will do something weird. It expected A to be an integer. It's a string. Weird things will start to happen. This is a contrived example because it like starts from like Stripe codebase, and it's contrived in a sense that you can argue that you can eliminate the untyped file and just say that everything should be typed. In reality, that's not how it's going to work, because first of all, we're gradual. You can't get everything to be typed at the same time. Second is that after you're gradual, you'll always have external libraries. And external libraries not coming from Stripe, they're untyped. And you need to make sure that external libraries call into you correctly. They can like store fields that you're going to read in typed code. They're going to call into your typed code via like callbacks and via passing functions that implement interfaces that they know of, or like just name-based dispatch that Ruby sometimes uses. And it's important for us to continue checking this. At the same time, we also found that it's very useful to find bugs by finding that code. Let's say if you believe that something cannot happen, let's say if you have a function that takes an integer, and somewhere in this function, they're starting to check if it's a string, most likely that's a bug. Most likely somebody misunderstood, somebody mistyped a variable, or somebody is handling the case that could not happen. It became a common way to finding bugs and coming misunderstandings. which meant at the same time that typed code cannot protect itself statically, because it was trying to protect itself statically will complain that your protection will never trigger. So, okay, this was like the guiding design principles. Now let's discuss how did it play out. So here's the timeline. We started implementing the project in October 2017, and it took us around 8 months to build it from scratch. During those 8 months, we paired with 2 teams. The simplest project that we believe we can have adopted in Sorbet, which was our internal bot that organizes CI interactions. And one of the hardest projects at Stripe after we succeeded with the easy one, which is one of the hardest projects at Stripe, which is Stripe Connect. So by pairing first with the first one, we were able to make sure that our general direction is correct, our general decisions are correct, but then by partnering one of the hardest projects at Stripe, we made sure that if you take us to the full complexity of the needs of Stripe, we can support it. After making, yeah.
So how did, before you started working on that unit that several months before just working before rolling out, how do you sell it internally? That's a good idea to do before.
Great question. So, Sorbet is a project that started by 3 people. Paul Tarjan, who's the current head of developer productivity, was the biggest voice for having the project. He worked on a similar project at Facebook called Hack. And from his experience, typesystem delivers things that our users asked. Specifically, Stripe organizes developer surveys. And in developer surveys, people repeatedly asked for things like clearer interfaces, better documentation, better code organization, better modularity. And Paul's belief, which is shared by our team and now shared by everybody at Stripe, is one way to deliver this is a type system. It makes your contract more explicit. It doesn't make it perfect, but it's a huge step in doing this. It gives you a tool where you can make your contract clearer, and by using more complex types, you can make it even super clear, but there's also diminishing returns. It took some time to get buy-in. By the time I was hired for this project specifically. Great question. Overall, even after it, all the metrics that we have for productivity improvements and things like this are very indirect. We have a lot of positive sentiment from our users. I'll go through it later, but it's very hard to measure anything in productivity. We know for a fact, because we observe incidents at Stripe, that entire classes of incidents have been eliminated. This is some metric that we have, but at the same time, it's very hard to assess that users and developers at Stripe can write code more confidently, because how do you measure confidence? Yeah, great question. Okay, after building it from scratch and trying out on a couple code bases, we started rollout. Rollout meant officially saying that everybody at Stripe is free to try it out. And the more they were trying out, we didn't ask people to try it in a sense, we asked them to consider trying it. The reason for this was that in the original days, we're finding a lot of problems that were mostly UX problems that are specific to some patterns of Ruby. And we knew that the more of them we support, the easier it is to adapt it. And at the same time, we believe that we'll have a lot of value proposition. So in early days, some people at Stripe were saying that we're taking the best way, we took away the best parts of Ruby by introducing this project. But at the same time now, there are some of our biggest voices who argue that we're one of the best tools that exist for developer productivity at Stripe. So it took some time for people to observe that that's a tool that they want. And it was important for us to make sure that they're comfortable with the process. Yes, please.
If you don't mind me asking, how did you get buy-in from the internal people that
So different team, should I be repeating questions? I think they're, okay. The question was, how did we get buy-in from internal people, I guess from engineers? Originally, we had some groups of people who were pretty skeptical, and their code bases were for a substantial amount of time, like several months, not typed. But then they saw how much improvement and how many guarantees did it give to other people. It frequently became something that was like a knowledge that you expect to have the guarantees. When somebody as a user is coming to your code base, for example, the way they used a lot of newcomers learn legendary coded Stripe is by going to type it. So you have some old code that's important, but nobody no longer understands it. One common tool now to understand it is go type it. See if your understanding about types is correct. And it became a very powerful tool for both writing new code and exploration. So we did not do much in like going to people and convincing that they should use it. Rather, we started sending PRs to them that will type their code. And we said, if you want to accept it, great. If you don't want to accept it, okay, fine. And quite quickly, people saw how much value it introduced it and started accepting. And then finally, this is more the state where we currently are. We open sourced it recently, and now we're working on tools which are derivative to the type systems. They're not necessarily the type system itself. Their tools are refactoring, ID integration, autocomplete, quality of life things for developers. So here's a bunch of errors that we found when doing the rollout. One of the common errors that we found is here, you're referring to a constant called hello. You're instantiating a class called hello. Well, if you don't have a static type system, the only way you learn that you mistype the word hello is by running this code. So in order to make sure that you don't have this error, you want to make sure that all codes in your code base gets executed. Stripe did have good test coverage, like more than 90%, much more than 90%. But at the same time, it meant that in order to discover this, you had to go through a lengthy CI cycle. 15 minutes, 10 minutes, 20 minutes, depends how you're doing it. Having a tool that's able to tell you this in seconds was super helpful. And also, we're trying to make it into a nicer error. So if you like compare the error that Ruby gives you, it's not very cryptic, but it's like uninitialized constant hello. What we can do is we can say unable to resolve constant hello. And actually now we'll also tell you like, did you mean hello with double L? Today we can find this error in 100% of code at Stripe. The second one is undefined method errors. So here you're calling a method, you're intending to call the method greeting, but you called it greet, which means when you start calling the thing in Ruby, that's what's going to happen. You're going to have an error called undefined method greet. The moment you introduce type true here, that's the error that you get. And like similarly today, you actually get the error saying that did you mean greeting? And similarly, you don't need to run the test suite. Rather than having an iteration cycle of minutes, tens of minutes, you get it in seconds. And recently with ID integration, milliseconds. And this is the property that we're going to ensure in 80% of Stripe code base today. At the same time, it's also more than just errors. It allows you to specify what expectations you had as to a method. How do I use method? Or how do I, as an author of the method, expect my users to use me? And the most common error, one of the most common design questions that we had for when building Sorbet is the hard decision that Scala is attempting to make in Scala 3, and Java didn't make early, is we're trying to solve it for a $1 billion mistake, which is not, in Sorbet, types are not nullable or nullable, however you call it in language by default. The null pointer, null PTR, 0 in C++ does not inhabit every type. Which means if you want to take nil, you have to explicitly list it as a type. So it's not fine to pass nil, which is like Java version of null, to a method that takes a string. And 62% of methods in Stripe currently have a signature. We can check it for a majority of them. So this is a recap. This is like some indication of how much checks we can do now. Yes, please, Mike. Yep. Okay, the very early developers were us. The way we integrated this is, do I have slides about this? I don't think I have. Yes, I don't. The way we originally integrated this is we created a CI job that would ping us if it fails on master, which means tests have succeeded, but the type checking has failed. So this was the original way it worked, and only for us, only the team working on Sorbet. What this gave us is that we were able to see whether we're reporting bugs, which are more like our bugs rather than user bugs. We worked on having really good signal to noise ratio so that if typechecker is complaining to your tests are very likely to fail. Stripe had a good testing, has a good testing culture. So it's mostly about optimizing time to response. The next way we rolled it out was a batch type checking tool. It was a script that you were to call, and it would take something like between 6 and 10 seconds, and it will give you error messages or say that there are no error messages found, good job. And that was the mode in which it was for more than a year. Then some other folks found it super useful and contributed a Watchman integration to us. That's the way they like to work. Effectively, they have a spew of type errors in their terminal. It ended up being really hard to balance because the error message order matters. Because effectively, the moment we report a first error to you, we'll try to recover from it. And we'll continue like doing parse and doing type checking. But when we recover somehow. So after the first error, all next errors are potentially bullshit. So Watchman integration, though being useful in the workflow, it created a conflicting preferences about how errors should work. And more recently, it's an IDE. From our experience, my previous experience with Scala IDEs, majority of developers consider time to response in IDE longer than 200 milliseconds as slow. So that was our goal. Today in our multi-million line of code, average response is 3 milliseconds. So we're comfortably good performance-wise. IDE is in beta at Stripe. It's an open beta, but we should probably stop calling it beta because more than 50% of developers use it. Does this answer your question? Great. Okay, so now, other than like just what do we cover in terms of like errors, some like feedback from users. Somebody is saying that like the package that they touch only once every never. Historically, it was taking them harder for them to understand how it works. Now, as they added types, it's much easier for them because they need to spend less time getting back their understanding to the same level. Similarly, a lot of people say that they use typechecker as like a pair programming body, where a typechecker will be telling them their feedback as they're writing code. Their code is yet to be written. The code still doesn't parse, but typechecker is already able to see, you know, you didn't cover a case here, or like you're calling the method that doesn't exist. This is super helpful because unlike tests, which needs your code to parse, having this feedback very early as you're writing code helps you design better code. It helps you discover misunderstandings and misdesigns before you finished your multi-hour implementation of a complex thing. It makes your iteration loop smoother. It helps you, it steers you towards a better design. And then on Hackathon, I wrote an IDE plugin for us originally several years ago, 1.5. And people were super excited about this. It allowed them in a lot of situations, you have a common variable at Stripe called merchant. And merchant can state either for object that describes merchant, or like a ID of merchant, or a bunch of other things. And it's always called merchant. And if you frequently wonder, I have a merchant here, so what is it? Is it object? Is it a string? Is it either? And having a tool that's able to reliably do this for you is literally saving engineers like tens of minutes of research to make sure that are all the colors passing a string consistently, or should I like be defensive here? And yeah, it's fast. People like it. People love writing tests at Stripe. They still love it, but recently they're frequently deleting them because the things that historically were done by tests can now be done statically. Yep. Okay, so what we learned. Sorbet and typesystem in general are a powerful tool to fit many needs. If you build the type system right, you can have people who want to be strict because they're writing critical software. They want to make sure that everything is super safe and they'll be happy. At the same time, if you do it carefully, you can also have people who want to have the least interruption, who are like moving fast and breaking things. And if it crashes in production, whatever, YOLO, we're still figuring out what it should do in production in the first place. If you do the right decisions, you can have both of them happy. Another thing that we did, which was very important, is we built automatic tooling for adoption. The adoption here, the 80%, were mostly driven by a few engineers. This was driven by tools which allowed us to type the code automatically, to find which files can be type checked now, which modifications to them should be done to do type checking, to find which values do methods return, and automating this and concentrating the pain on a few people was super important for success of this project. Yep, and this goes more into rollout. So after the rollout, which took 7 months, and that's how it got to the metrics, we moved to open source. And that's partially what I'm going to dive closer here in case somebody is like looking to do Ruby code. So the most impactful tool that we're building now is the IDE. In IDE, you're able to have even faster iteration loop than 10 seconds. You can have milliseconds. And at the same time, it allows you to have knowledge that the types checker had about your code base. But before this, the only way it was used to is to verify you. Now, rather than like giving you instructions, you're doing it wrong, you can start asking it questions. How do I do this? You can like hover over something, you can hover over method and see its signature, you can get autocomplete, you get things like this. So first of all, you get error messages, which you no longer have to like scroll through a huge output. You can just jump to the error in the IDE and see it there instantaneously. You also get hover. You get the jump to definition. You can like click on the methods, ask where it is. This is super important. If you haven't ever worked in like either Ruby or Python or similar languages that don't have a type system, having ability to know what you're calling, in particular if a method has a common name, is super awesome for productivity. And finally, having an autocomplete. Like, what can I do with this thing? What arguments does it take? What's documentation for it? You no longer need to like open some HTML page somewhere that has yard doc. You can have it in autocomplete, see what can be done with it, and yep, see what can be passed there. Like this method takes a string. You know, you have a documentation, like when you autocomplete, it tells a string there. You see the docs on the right. And you instantaneously replace a string with what you were intending to pass. Yes. Sir, a charge ID is local variable. Yeah, this.
Go back, I just want to read it.
Yes. Great question. They weren't directly inspired by other languages. They were inspired by reality. By reality that typed false is effectively what was true at Stripe at the time before Sorbet started, as in without a sigil. That's what was the status quo, and we'll try to verify as much as possible before running tests. Typed true is what can be easily adopted without much suffering. And the type true is what majority of our work went into. Type strict is mostly geared towards like internal APIs, where you want to say that like, I might be having some come out of untyped code internally, but it's like encapsulated in me, but I want my users to know how to use me correctly. Like I'm exposing good interface for users. And type strong is like choose static channel language of your choice. So it's not directly inspired by majority of languages. Some other languages like Hack have similar like typing levels. And in some of them, you can like disable errors one by one. We found that disabling errors one by one is freaking confusing because like similarly, like you have error recover, you just silence a single error and you recover it. Now you create another error. And the reason for the secondary error is you like incorrectly recover from the first one, but nobody ever saw the first one because you silenced it. So in our experience, like having smaller number of well-designed workflows is better. And we found that those workflows serve a majority of users at Stripe. Thank you for a great question. And then, okay, there's Sorbet.run website. That was also the QR code that you had on the screen when you joined. We compile Sorbet into WebAssembly and we ship to you in a browser. So this is effectively an IDE as a web page. You can use like right click there. You'll find all the things. You'll find jump to definition. You'll find autocomplete there. If you go there on your phone though, because we're using the same thing that Microsoft uses in VS Code for the editor, and it does not work in mobile browsers because it doesn't work with touch. So you won't see the majority of features in mobile phones. So try it on laptop. And then, okay, the state of Sorbet. We're working together with Ruby core people. We're part of the working group working on bringing types to Ruby 3. Ruby 3 will have types. We're collaborating with the Ruby core team to find which additional constraints, which are additional requirements and necessary for type system of Ruby 3. It's an active ongoing work, and yep, Ruby 3 will have types. We're open source. In order to verify that the open source will be successful, we ran a 2 or 3 month long beta where we were adding 5 companies every week or so and onboarding them and seeing what's their experience like. We wrote the docs, we published it in a private website. They were able to see how we would presumably adopt Sorbet. For the first 5 companies who tried it, nothing worked. For the last 5 companies who tried it, everything worked, and that's why we open sourced that time. So if you're looking to have an open source project, in particular project in tooling, this worked wonders for us. Single data point is great. From our experience, it's great. Add more data points. We try to make it more similar to how open source people expect to use it. It's distributed as a gem. The gem has C++ code inside, but it looks like a gem. We try to automate as many things as possible. The tools that we built at Stripe to automate adoption are part of the tool that's open source. It's able to report the same metrics that we measured, so the team can track progress. It's able to automate guessing types. It's able to automate adding type sigils to files and raising the typeness levels of files. Most of the tools that we built internally that worked are open source now. It's also a collaboration with other companies. Coinbase, who were one of the early adopters of this, helped us build supports for open source gems. Stripe is a monorepo, as I said, which means Stripe doesn't really use internal libraries. In a sense of we don't package them as a libraries, they're just code. So, which meant that at Stripe, we didn't really need to build support for like depending on somebody else's code that frequently changes. Like we build a huge file that like supports all of the gems that Stripe relies on, but we didn't need to like piece by piece adopt it or like piece by piece cut it. So the open source tooling for supporting Ruby libraries called gems was built by and contributed by Coinbase. Ruby has a lot of DSLs. DSLs do magic. When you do magic, type system freaks out. Like for example, if you write a method and this method breaks a bunch of, if you write a method call and this method call for you calling the method brings a bunch of unrelated methods to existence. Just because you just called a method, new classes gets defined, new methods get defined. Then if you try to like figure out whether they exist, type system may argue that they don't. And then you'll get frustrated. So we built support for DSL extensions where you can write Ruby code to say that this magical call actually introduces new methods. It was built by Shopify, who uses a lot of DSLs, and they're able to build DSLs and support their use cases. Yep, you write like a Ruby file that implements it. This is a small demo that implements the previous one. Yep. So that you don't need to know C++ to start doing that. And we made sure that you can type check Rails. We're started by type checking a few Rails projects that we found in open source. One is when you instantiate Rails, Rails can like build a default blog. We made sure we can type check it. We also type checked GitLab, which made sure similarly that we can type check small things and big things, how we did it internally. And then we worked with other companies who are part of the closed beta to make sure that they can adopt it. Many of them are in similar high degrees of adoption as we are, though they're yet to talk about this publicly. And important thing for us was that the moment that you run Sorbet on your Ruby project, something should work by default, which means when you run it, it will figure out which things can type check-ins now. So like if you're in particular on the Rails project, after you just run Sorbet init, what you get is 120 files are typed and 2 files, we believe there are type errors and they're not typed. They actually use metaprogramming magic that we did not support. And that's why our actual errors there are not correct in the sense that Ruby there works, but we don't understand what it does. Similarly, if you do it in Ruby gems, you get high precision of typing instantaneously. You just do it on rubygems.org, the actual website that serves as a way to like navigate as a web page libraries in Ruby world. Just run the tool and automatically gets you to 60% typing files by files. And in GitLab, you get to 20% typing on spot. Type checking Rails was interesting because it's a big code base and a big new way of writing Ruby that's dissimilar from ours. And we were very concerned it will be hard to type. Prove that we need to build a single feature to support it. That's before this hasn't been used at Stripe, but later we actually found some uses for it at Stripe. Feature is actually quite interesting if you're curious about the details. In many languages, let's say Java, this inside method is defined by the method. In Ruby, in some cases, this, which is spelled self, can change. So we needed to introduce a way for you as a library to say that I'm going to do some magical stuff and your self is going to change. And it's going to change to this other type, which is kind of funky, but something else in Ruby uses. Okay, and now for closing, we have editors on interactive development. Editors are yet not open sourced. The core Sorbet itself is open sourced. It works in Rails, it works in many projects. There are some cases where making it work is painful because you have to go through adopting in a big code base. And our experience suggests that the best way to do this is to concentrate pain on a small number of people who will grow bigger muscles in doing this and use the automatic tools rather than spreading the pain. We've seen this process work for us. We've seen this process work for others. And we'll also have docs for it, which are live at sorbet.org. Thank you. And please ask questions. Yes? So there are 3 ways we support gems. The very first one, and probably the most commonly used one today, is this thing that Shopify built, this thing that Coinbase built. I'm having a hard time finding slides. So similarly, how you can do this for Flow, similarly how you can do this for TypeScript, you have a repo under which you can publish type annotations for existing gems. That's the most common ways you get like decently good types for a gem. A better version is if a gem ships with an RBI folder, we'll consider this folder as like type annotations for this gem. And lastly, the fallback is that the same way how we find all the metaprogramming, when you run SRB init on your project, We'll load every gem separately and we'll see which methods did this gem define during loading. And we'll write them down as an interface, but with everything untyped, which means we'll know from like real loading of this gem, what did they define. It doesn't work perfectly. Some gems don't actually load everything eagerly. And we sometimes need to like hard code that's like, if you're loading AWS gem, please also like refer to these few constants because they like trigger more loading. But overall, so far, it works really well because like 50 companies or so effectively brute force the majority of commonly used gems, and we now have special casing for them. Thank you for a wonderful question. Yes, please. Yep. So for those who are not familiar with Ruby, you can take an array and you can say, take elements of this array and pass them as separate arguments for another method. This is called splat. So this is like a method call where rather than passing arguments by one, you're saying just extract arguments from this array. If array is untyped, like the thing that you expect to be array, it's going to be fine. If we know it's an array, it will depend whether we know how many elements are there in an array. Sorbet has typed, which like is array of like 2 elements. The first one is integer, the second one is a string. But you can also have an array where we don't know the arity of array, how many elements are there. If you try to splat an array that we know the arity, we'll check it fully. If we try to splat an array that we don't know the arity, we'll complain. And the way we have backdoors for every kind of complaint, both static and runtime. The most commonly used backdoor is called t.unsafe. You say t.unsafe receiver.call, and this moment will stop complaining about anything, which means that you make it explicit that you're making a call that we cannot check for safety. So, and we can also auto insert this into your code base, like t.unsafes everywhere. So that's how we support it. We found that this is like the right balance between like, when everything is untyped, you don't want us to yell at you. But the moment you start having some kind of typed stuff, you want to have more checking. And that's the balance that we found so far to be working well. Thank you. Any more questions? Yes, please. It was not the most important goal, but having a story for performance long-term was a goal. Our original intention was that we're going to build something that should run in under 20 minutes. Because this is worst case how long our CI took at the time, and we didn't want to make our CI slower. That said, like when we rolled it out, it was like taking around 4 seconds. So like we overshot performance, which to be honest, we didn't work in performance at all. We like overshot by design rather than by tuning. And since then, like our code base doubled a couple times. And so we're no longer in like single-digit seconds, we're double-digit seconds. But then here, it was not the most important goal, but I believe it was a very important thing for getting people who are skeptical of the type system on board. Because one way that they argue is that, why wouldn't you run tests instead? And one way you can be more useful is to say, well, first of all, you have to write tests. Second of all, they take time. So this having it be faster made it value proposition much more clear. If we weren't as fast, I believe that we would have still gotten adoption from a substantial group of people. I'm not sure if it would have been so pervasive as it is today. And then finally, we believe in monorepo. We believe in making it easy to like restructure code, which means that the boundaries at Stripe change frequently. So far, we would like to have an effort to be able to like cut our code base in clearer pieces. This effort, without having a type system before you, And conditioning building a type system on it will be really hard. So tools like Java or C or Scala frequently, performance-wise, depend on how much code do they need to load to type check a single file. They do lazy loading, partially because belief in Java early was like the Java will be the internet, so that like class names mimic websites, and like potentially you can have like the moment you refer to class as a specific name, it's just like URL class loaded from the internet, and you can't load all the internet on your drive. It's like partially there was a vision there, but partially this was the way how language was built, that you start loading it one by one. Contrary to this, in Ruby today, and in Ruby at Stripe, which is a subset of Ruby, substantial number of checks can only be done when you loaded the entire code base. Which meant that the standard way to make like compilation or like type checking faster is by cutting in small pieces. Given the constraints that we knew about the Ruby at the time, we believed it will not work. Specifically this, that you need to, in order to type check Ruby, you need to load the entire code base and understand it entirely, we believe was the biggest hurdle to type checking Ruby compared to languages like JavaScript, compared to languages like Python or other static languages. Great question, very deep. Didn't you have a question too? Could you repeat again? What were the things that didn't work well? Depends how you count this, but generic system was implemented 3 times. So we ended up each next one being simpler than the previous one. So the original question was, how much complexity do we need to model all of it? Like all the use cases we wanted to support. And then I was cutting it down smaller and smaller. Like in retrospect, it would have been easier to know what do we end up with, but the exploration took like a month or so. So like, I'm yet to know what's the best way to have learned the information that I learned in this month. But like going into a hole for a month without a clear vision for a team, how long it would take, was a leap of faith. What else? For a long time, we've been postponing trying Rails because we believe it will be hard. That's one of the big reasons we postponed open sourcing. I'm not sure it was the best idea in the end because like it ended up being easy, but maybe it was easy because of the pre-work we did. So like we ended up being very focused around our specific use case that we had, which is Stripe. But at some point we had 500 companies asking to get access to it. Like at some moment our developer relation teams was building tools for us to be able to reply to them. Because like just amount of time necessary to reply to everybody was very high. And like some of the customers at Stripe were literally asking like our execs of like, can we get access to it? We're like, you're a big customer. Can we please? So I'm not sure whether we strike the right balance there. I know that it worked out well. I wonder whether there was a better way to do this. Hindsight 2020. Yeah, I'll stay till the end. Yep, I'll be around. Please feel free to come and ask questions. And let's have the next speaker.
Thank you.
All right.